Okay. So we need to continue our discussion about the shell method, but what happens when we're rotating about a line that is not the x-axis or the y-axis? Okay? What is that going to affect? Is it going to affect the height of our shell?
No.
No. Okay, the height of our shell is based on the rectangle that we draw in there. That is not going to be affected. What it's going to affect is the radius. Okay? And the radius is always going to be the distance that rectangle is from the axis of rotation. Okay. So I'll remind you that when we set up our integral, we have the 2 pi times the radius times the height times the thickness. The thickness gets replaced with dx or dy. The height gets replaced by the length of the rectangle, and it's the radius here that we need to focus on. Okay? So if we were going to rotate about this line x equals a, any given rectangle, how far away is it from this line x equals a? Turn to your neighbor and have a discussion. 30 seconds. What do you think? All right, I wanna hear what you think. What is the radius? Lauren, what do you think?
A minus C.
A minus C. Is it A minus C? For that point, says Sean. So what if we were to write it in general terms for all of the rectangles we could draw? Okay. I like the A minus, Lauren, but we're going to write it as A minus X so we can talk about, in general, any of the rectangles that we would draw in there. Okay? So do you agree that any rectangle is X units away from the y-axis, right? That's what we called our radius when it was the y-axis. Well, now I want this distance right here. Well, if each rectangle is X away from the y-axis, then we're going to take whatever this is, A, and we would need to subtract out X to get that radius. In this scenario, our axis of rotation is to the right. So we are doing that concept of right minus left in this case to figure out the radius. If our axis of rotation were to be on the left side, we would have to switch those around. I'll show you what that looks like in an example. Okay? The only thing you have to change, though, is the radius. Okay? The height of the rectangle is still going to be in there, and we're going to keep it the same. It's just the radius we have to worry about. Okay? So, take a moment and write down this region and go ahead and draw it for me. Okay, is this our region right here? Y equals 4 minus x squared is a parabola, opening down, up 4. We're cut off by the x-axis and the y-axis. What is this coordinate right here?
0, 2.
Try that again, Colby.
2, 0.
Thank you. Okay. So we want to take this and we want to rotate it about the line x equals 2. You can make a dotted line, you can make a solid line, I don't care. Okay. Whatever works for you. And I'm going to draw in parallel rectangles, which means they would have thickness dx. So when we do our integral, when we set it up, since we are in respect to x, our limits of integration would need to be 0 to 2, because that's the x interval that our region stretches about. Okay, we're going to use the shell method, so we have 2 pi, we need a radius, and we need a height. So let's talk about the height first. The height of each of these rectangles would be what? 4 minus x squared. Okay, let's talk about the radius. Each of these rectangles, you need to think about how far they are away from the axis of rotation. Okay? Each one of these rectangles are x away from the y-axis. So from x equals 2, they would be 2 minus x away. Before you punch it into your calculator, are there any questions on how we set this up? Math 9, that bad boy for me.
Oh, yes.
I appreciate your enthusiasm.
Senioritis.
You proud of yourself because you have senioritis?
I got 40 pi over 3.
40 pi over 3?
I got the exact same answer.
Okay. Would you like to try one where the axis of rotation is on the left side? So we can see how that is different. All right, now, since we don't get to actually do our bundt cake lab, we'll just create one in our next example. I told you that we can't. We've had too many Sundays. We don't have time for that day.
But you can't eat one.
You just told me you're gonna make a non-doing cake.
I always do this example. I was just trying to
Yeah.
in an office.
Is it supposed
Get wrecked.
Should that be an equal sign? Yes. Thank you, Lauren. Here is an over. Here is
And then the sun will be and the sun, that's gonna be the worst part. Like, the sun will be like,
I think it's gonna
warm out there.
I don't think April's gonna be warm.
There's
I
gonna
think
be
May will be
snow on the
warm.
ground till
April
May.
is always rainy and chilly. You know what I mean?
Miserable.
Okay, so I want to remind you of an efficient way of graphing this parabola. Factor out an x. We have x times 3 minus x. So our intersection points are 0 and 3. So there's our parabola. I don't really care right now what the vertex is. You can find it if you want, but it's not really going to make a difference. Okay? So we are bounded by the parabola and the x-axis. So we are talking about this region right here. Nice carny colors for our UNK. Did you say gross to UNK?
I was thinking of the high school.
Sorry, UNK colors.
That's
Okay. Or Sweden colors.
Sweden. Yeah.
Fun fact, I am 50% Swedish. Okay, we are going to rotate around the line x equals -1. Okay, so I have a rectangle with thickness dx. That's really our only option here. Okay, splitting this up into in terms of y would not be fun. And since that rectangle is parallel to x equals -1, we're talking about the shell method. Okay, so we have 2 pi integral. We need radius, we need height, dx. Okay, let's start with the easy parts. Our limits of integration would be 0 to 3. That's where those intersection coordinates are. Okay, the x values of them because we're in terms of x. Our height, the height of those rectangles are x minus x squared. Okay, now for the radius, how far are each of those rectangles away from x equals -1? Aha. So this distance here is x, because that would be to the y-axis. And then we went 1 unit further. So you can think of this as right minus left. Instead of a minus x, we have x minus a. Or you can think about the picture and you can see the distance to the y-axis is x, and then we have a little bit more. Okay? I don't care how you see it. Pick one that sticks in your brain better. Which one makes more sense to you? Okay? When you math 9 this one, what do you get?
95. 45 halves, also accurate.
Hey, but you know what the good news is? If you put 90 pi over 4, am I going to count any points off? Nope. What?
That's cool.
Then I should only for you then. Okay. I hold him to higher standards.
That would
Okay.
make sense.
I do not require you to reduce, so take that off your worry list. Okay?
I think I'm just going to write it not fraction.
But what I don't want,
Multiply that.
what I don't want is 22.5 pi.
So if I
No
were-
decimals with pi. Only fractions with pi. All right, last example.
You'd have to not put five.
Can I do that on my quiz for that?
What?
That you're just like really dumb fractions like multiplying by.
Oh, don't be obnoxious.
But they're still and you simply don't have to do this.
I wouldn't. This is the last one. That'd be too much.
Yeah.
That'd be too much effort.
I mean,
I'll do
Yeah.
no way. Just above this.
Okay, x equals y minus 2 the quantity squared. What are we dealing with?
Square root, but both
A sideways parabola that has been shifted
choose who.
up 2. And then y equals x.
It's about the line. Is this y equals 1?
Oh, well. All right, so here's our region. And we're rotating about y equals -1. Okay. Now, here's an example of a time where we could choose dishwasher versus shell method. However, if I were to draw dx rectangles, top minus bottom would change. We would have to do 2 integrals. However, if we draw horizontal rectangles with thickness dy, we stay consistent from left to right, right to left, however you think of it. And so we're going to have to do 1 integral. Okay. Our intersection points. This one's easy. What's this one? This one's 1. What is the y value of this intersection point?
4.
4? Let's test it. 4 equals 4. 4 minus 2 squared equals 4. Okay, I'll trust you now. Don't eyeball it. Please be accurate. If you don't know it, set them equal. Y equals y minus 2 the quantity squared. Okay. Let's talk about the height of our rectangles. Right minus left would give us y minus 2 the quantity squared. That is the height of each of our shells. The length of our rectangle. Our radius is always how far away our rectangle is from the axis of rotation. Turn to your neighbor. Tell him what it is.
So it's y plus 1.
Okay, so each of these rectangles are y away from the x-axis, and then we keep going 1 more. This is not one I would make you integrate by hand, because you would have to FOIL and then distribute and then distribute, and we're not all about that.
Okay, so we're going to have to receive that.
7. Emma, did you get something?
63 pi over 2.
Yep.
Yep, okay. I wasn't hearing anything yet, so I was worried that maybe it was...
Yep.
I have 2 confirmations.
Yep.
Oh, there we go.
Oh, yep.
So we have 14 minutes left. And for us to make good use of our time tomorrow, remembering the difference between shell dishwasher, I really want you to nail down this homework assignment. So if you could do 2 to 3 problems before you walk out of here, that would be ideal.
I want the whole thing.
I'll settle for 2, but I'll take 3. I can't remember how it starts with either the calculator versus non-calculator one. But your goal sheet will tell you which ones you should integrate by hand for practice.
462, 23.
Hurry up.
Seven, 8, 29.
Very good.